Welcome to a spam talk. I am going to give you basically two topics. First one is a little bit serious, but the second one is very stupid. The first one is kind of a pacemaker experiment using the wind stress forcing. So this is along the line of England et al. Paper, and try to explain, or not, how to say, try to attribute the present hiatus. So this is an, how do I use this? The red one? Oh yeah. Okay, so this is an England paper, and says that the strengthening trend of the equatorial Pacific wind stress might cause sustained IPO negative phase. So what we have done is partial wind overriding historical experiment, PWO. This is ordered by one of the reviewers, but we originally used the words like partial assimilation or pacemaker or things like that, but the reviewer didn't like it. So we have to call it partial wind overriding, the same as replace the wind stress, not to replace, add observed wind stress anomaly to the coupled model run. And one of the merits of advantages of this type of experiment is that you don't have to worry about the imbalance or additional heat input to the coupled system, so that you can hopefully better discuss the global mean trend and hiatus-like thing. So this is an example. The PWO HEST is the historical change of the wind stress anomaly has been given to the model. Oh, by the way, model only Pacific area 30 to 30 degrees, equatorial Pacific only. So this is top of the atmosphere radiative balance. During the hiatus period, it has a positive number, and then this is a satellite estimate which has the same order of magnitude, so that the system seems to be working okay. Okay. So this shows the this is a Nedium 3.4 SST anomaly observed, and this partial I can't remember PWO experiment. So it almost completely reproduced the interannual variability of Nedium 3. And then this is anomaly correlation coefficient. Of course, it's good and over the Pacific area and in some other areas. Okay. So this is the surface SAT. What's that? Surface air temperature anomaly change from the previous decade to the present decade. This is observation, and this is the simulation. And Pacific IPO signal is present, and some other area, Eurasia, seems to be okay. So this is a spatial distribution, and then this is a global average. Observation is black, and red is the wind pacemaker experiment, and then this is the CMIP models. So including the interannual variability, the Pacific wind stress seems to be able to dictate the simulated model global mean air temperature. And since we don't have to worry about the heat budget imbalance, we can do additional experiment in which all the anthropogenic forcing of the couple model has been suppressed. Therefore, no CO2 increase, no aerosol increase, and things like that. So this is, the blue line is something like this. Still, wind stress forcing is given. So this has a drastic impact on global mean surface area temperature time series. And
large cooling in the year
what's
2000.
2000?
It's the La Nina, right?
La Nina, yes. And this is,
Okay.
yeah.
It's not forced, but
19.
And wind stress, observed wind stress anomaly, intuitively we think that it may not include too much of global warming or anthropogenic signal. And later we confirmed that that is the case. Therefore, these two runs may be used to estimate the contribution to the hiatus. It's already reproduced. From anthropogenic forcing and natural variability. And so in order to do that, you have to first verify that the wind stress anomaly forcing has little to do with anthropogenic warming. So this is a very difficult thing. Okay, so this is a EOF, first EOF of the observed anomaly, has this sort of pattern and this sort of time series. Oh, what? So this is EOF of atmosphere only experiment in which the sea surface temperature, observed sea surface temperature is given. Total anomaly, not including anthropogenic and natural variability. Then this is the first EOF of that AGCM run, which is very similar. And in the same way, AMIP run can be repeated without giving the anthropogenic component, both in SST and in atmospheric composition. That is not shown here, but the blue curve here is something like this. Therefore, in terms of global mean surface temperature, this natural run doesn't have the warming, recent warming, but the historical run has a warming. But all the pattern, variability pattern of the wind stress time series, either observation or historical run or natural run, has almost identical time series. Therefore, we believe that the observed time series, especially the principal part of the observation variability, has little global warming signal. We have analysis of the higher order US, but we judge that we may be able to say that the wind stress forcing doesn't have significant anthropogenic signal. Then we can divide the temperature signal in wind pacemaker experiment between the non-anthropogenic signal and rest. And then we can estimate that the rest, therefore the anthropogenic contribution and the natural contribution can be estimated. And then this is a decade by decade estimation of the global mean SAT, surface air temperature. And blue is the natural contribution. And the natural contribution in this last decade is very negative. And then anthropogenic, this is black is observation. And external means what I called anthropogenic. So this is this. And then if this is included, then this becomes this. So in this way, we can estimate the fractional variance of anthropogenic contribution and natural contribution. Then that is written here. 1980s, the contribution of the natural variability used to be 47%, and then it's decreasing in spite of the hiatus, like signal. So we can say that the hiatus is due to the wind stress, namely the natural variability, but still that contribution is decade by decade decreasing. Therefore, the global warming is steadily continuing. So in this way, by the way, this is a ocean signal for the hiatus period. This is depth and latitude section. This is observation. And then this is the results of simulation, have some similarity. And then this is a decomposition into the natural part and an anthropogenic part. Anthropogenic part has a high latitude deep signal indicating AMOC type of circulation is involved, but natural variability, IPO type of variability, has more signal in wind-driven circulation type. And this is a additional thing. If you carefully look at the hiatus trend of the surface air temperature, there is a seasonality, and in winter it's suppressed, but in summer it's increasing. And this simulation reproduces this, but we wonder that why land surface temperature is keeping so high. And so this is another study using AMIP type of the simulation with and without the anthropogenic effect, and I try to see the frequency of a heat wave over the land, and then try to separate the different contributions. And SST contribution that includes the anthropogenic warming, and then CO2 contribution, that is a local change of the heat balance. And then surprisingly, I mean, to me, surprisingly, SSC, of course, is important, but CO2, local warming effect, is also contributing to the frequency increase of the observed heat wave. Heat wave is defined as the monthly temperature anomaly that exceeds a certain threshold, 2 sigma or 3 sigma. And okay, so, okay, summary. Summary is summary of what I have said. Okay, so this sort of pacemaker experiment is interesting and fun to do, but nobody tells us that why wind stress, IPO-related wind stress became something like this. So we think that this time, before the hiatus, the Pacific changed under the influence of the Atlantic. So that's why the component C experiment exists. But that one, AMV, this is completely another study under review. But this is sea surface temperature historical time series. Has a lot of multi-decadal variability. And the sea surface temperature, I mean, AMV sea surface temperature, I mean, AMV index of the sea surface temperature. And then this is a coupled simulation, coupled model simulation, and that reproduces this one. And then this is an ensemble mean of, in this case, only 5 members, sorry, this is the work in progress. But anyway, so we thought that, we are told that AMV is a part of the natural variability, but we wondered that something is forcing this variability, and we are all aware of the Booth et al. Study, but somebody said that the Booth et al. Study might not be so universal, so that we repeated the experiment in which volcano and anthropogenic aerosol forcing has been suppressed. So, this very strongly indicates that a considerable fraction of the AMV variability might be forced. So, I think it is very. We have to be careful that of course, we want AMV to be totally dictated by the AMOC variability, dynamical variability. But since AMV is defined as the sea surface temperature of fairly large area, so that it might have some other contribution, surface contribution like aerosol. So in interpreting natural variability, forced variability, and so on, so we think we need some sort of this attribution type of the analysis. So the final part, do I have 10 minutes? No. Okay, so this is a fun spam 5 minutes. Okay, yes. Don't have to read. We are planning 100-year coupled atmosphere ocean reanalysis and refocus. Okay, stupid. Because we are fed up with only 50 years of time series, observed time series, to discuss multi-year variability and predictability and so on and so forth. So we would like to extend the available observation. And in order to prepare for CMIP6, we have been introducing ensemble common filter new data assimilation system, and we are now going to check with the recent period. But before that, we would like to make fun of this program, so that we'd like to check ensemble common filter is working like a compo type atmosphere, and then that is a repeat of the compo study. So since we have the coupled ocean atmosphere model, we try to do that in a coupled ocean atmosphere model. So we make a trial. Before the trial, we did some pre-trial experiment for 5 years or so. So if there is no data assimilated, then the product coupled model run and observation has no, this is the observed period, no correlation. But if you include the surface sea level pressure anomaly, then the mid-latitude atmospheric signal, oh, by the way, this is 500 hectopascal height, and then input data is surface sea level pressure. So the mid-latitude is improved considerably by introducing the surface observation. And then if you introduce a surface observation in ocean, sea surface temperature, then as you can expect, the tropical atmospheric upper air variability is...
Are they monthly correlations?
Monthly, yes, monthly correlation, anomaly correlation coefficient. And then if you give SLP and SST together in the coupled system, then we may be able to expect, the globally improved reproducibility. And then actual example, this is ERA, not observation, analysis. And then this is such surface data only assimilation. And then this is 500 hectopascal. Can you see the contour of 500 hectopascal? So the color is spread since this is ensemble. And then this is anomaly correlation. Not anomaly, pattern correlation coefficient during this year. So not bad. Then we went on to do some more than 100-year exercise. And then this is the first one, the only one we have. And our product is red, and hard CRU is the blue. And then MIROC 5A MIP, what's that? Okay, forget about it. And okay, we think that the earlier period, the subsurface ocean data has a lot of problems. Therefore, we have to confess that we estimated the first half of the 20th century trend of the subsurface ocean temperature.
Your microphone's not working.
Oh.
Dropped it.
From various sources, and then finally decided that the CMIP ensemble might be best estimate. So we dictate the system to follow that trend, not an interannual variability, but a long-term trend. So that sort of trick is necessary to produce something that looks reasonable. But this is a research topic. So this is an example of monthly anomaly comparison between the observation and analysis product for July precipitation. And this is a longer term comparison of the interannual variance between the satellite and product. And then this is Nino 3.4, and these are re-forecast trial. And since this is not anomaly assimilation, the full field assimilation, so that it miserably drifts. But if you remove, if you do the bias correction, it looks okay. So this is fun. Fun, but a little bit serious. We are a little bit serious. We are trying to gather the historical data and do the data rescue, and especially we are gathering the Imperial Navy of Japan, and they made a lot of observation in Western Pacific area, so that we are collecting and digitizing that data. So I'm not joking, but this sort of work may also be important to advance the decadal science. Okay, thank you.
If we have a contest for best logo, I think your spam logo may win. Questions? Jochen in your room.
I had a few questions actually. How is this effort connected or disconnected from GRA 55, the data assimilation part?
Oh, disconnected.
Disconnected.
They are serious endeavor, and we are a fun endeavor. But we have an overlap of the personnel doing it. This is the fun part, and this is serious.
I just want to make sure.
Yeah, well, yeah. But since we have overlap, and then some of the people in the same office as the GRA people, so that observational data handling and all this know-how we inherit.
In your data assimilation, what's the resolution, and are you using?
Oh, right now we are using a very low resolution version of 300 kilometer T42 and 1 degree ocean coupled model.
Covariances are coupled or just disconnected?
Okay, so it is called loosely coupled right now, and we don't use the covariance matrix and that all the way up to the top of the atmosphere. It's only ocean atmosphere interaction area. Yeah, lower atmosphere and upper ocean.
Arun, Wolfgang,
In your simulation experiment, you can just specify SST for a particular domain. And you can design experiments like the pacemaker. Don't have to give the SST.
Oh yes, yeah. But
Might think about that. Or
yeah, the partial assimilation experiment can be done, but still there is a problem of system drift, like a GFDL lady described. Even though this is the data assimilation, you know, we have to have some measure to counteract the system drift problem. Yeah.
In your backward extended analysis, we have heard yesterday also that the 20th century analysis the warm bias in the higher latitudes. So do you have an idea how to treat this?
Chris, would you say?
I say again, okay, the 20th century analysis is a bit warm in the higher latitudes, the Arctic. And you said you want to make an assimilation using this reanalysis. So how would you treat this temperature bias in the higher latitudes? This warm temperature bias there?
Oh, in
the
sea
Arctic.
ice or something?
Yeah, exactly.
Okay, very difficult. And we don't know. So we don't think that this reanalysis, final product of reanalysis is coming in maybe 2 or 3 years, or not like that. Maybe 5 years, 10 years. We just reporting. We would like to start that kind of enterprise. That's it. Yeah.
So the Decadal reproduction of the AMV
Yeah.
caused by aerosols was criticised because the global heat or the heat content didn't increase. So did you get it?
Oh, yeah, yeah. Bush et al. Study has been criticized that the that couple model simulation doesn't reproduce ocean heat content trend, long-term trend. And our simulation seemed to have cleared that problem. And there is another figure. Didn't intend that our model is better than yours. It's just happening. Yeah, but that difficulty has been cleared somehow. Yeah.
So I was just curious, the Japanese naval data you were showing, is that mainly sea surface temperatures or are there vertical profiles?
Not vertical profile. It's a sea surface temperature, sea level pressure, and typhoon.
So these data are not currently in any of the reanalysis products?
No, it's not digitized yet.
Yeah, actually, Clara wasn't here today, but she had a figure in her presentation comparing sea surface temperature warming pattern between ERSST and hard SST for the past 100 years. So they look very different across the Antarctic Pacific. So I was wondering if your technique, coupled simulation, might be able to address this issue of
If that system can just solve that problem, that would be very good. But I really don't think that the data simulation technique is not perfect. And then data handling, details of the data handling is more important. That's my intuition.